arg of z plus 2i minus the arg of z minus 2i equals pi over 2. So if you think about these as coordinates, the plus is just a double negative, isn't it? So it's z minus minus 2i. So let's mark off that point minus 2i then. And let's mark off this point as 2i. Okay. So now what have we got then? Well, the argument of z, this point z, the argument, the angle, take away the angle here, the difference must be pi over 2. So if you think about our scissors, I'm going to draw two lines. The point where they meet is the point z, and the angle between the scissors is the difference between the arguments. So if I just mark off a little dashed line and show you what I mean. So if I draw a line there, say, and the line there, then the angle between the scissors where they cross, so to speak, must be 90 degrees. So I hope you can see that. If I draw a horizontal here, say, then this angle here is going to be arg z minus, this would be the angle alpha, if this were alpha, say, minus, and then the angle beta, z, which is the point here, of course, would be z minus 2i. So this angle here is beta. So alpha minus beta, that angle there minus the angle beta. Now beta is a principal argument, so beta is negative. So basically you're just adding these two angles up together, really, in terms of their absolute values, and you get pi over 2 or 90 degrees. So I hope you can see that. So basically what it's saying is the angle between the scissors is 90 degrees. So the property where that pertains is for a circle, isn't it? If this is a diameter and this is the circumference, any triangle we draw that has on the circumference, the point z is on the circumference of a diameter, the angle subtended from a diameter to the circumference is 90 degrees. That's a property of a circle. So that maps out all those points here, so we can just draw our semicircle then, can't we? Like so. Now the only other question that remains is there the other side? Let's try and do it the other side and see what we get. See if the points here, whether it applies equally to those points. So here's the z that way, and here's the points that way, the line that way. Now the angle, let's have a look here. If this is the point z, this angle here, if we draw horizontal then at z, we can see that this angle here, right the way around from there to there, is the argument of z plus 2i. So this is our alpha in this instance, which lies between 90 and 90 to 180, doesn't it? There, we can see that from the picture of these angles. And the angle, the other angle, so that's that z minus this angle, you can see that that angle there is going to be around to here, from there to there, and that's beta. Beta is negative, so alpha minus beta, and again beta is between minus 90 to 180. So this angle, take away this angle, which is negative. When you add them up, you're going to get an angle bigger, aren't you? Basically, than the pi over 2. Because they're both minimum, they can both be as 90, take away a 90. So they're going to be bigger than pi over 2. Probably looks like there'd be 3 pi over 2 or something like that, perhaps. So that certainly doesn't correspond to this angle in here, which is 90 degrees. So it's only this side then, isn't it? If you think about it. So this is a circle. So let's do that then. Let's just try and do this equation for this side here. So here we have a circle. This is radius, is half the diameter, which is 2. Center at 0, 0. So it's x squared plus y squared is equal to the radius squared, which is 4. 2 squared is 4. And we've also got x is bigger than or equal to 0. Is it equal to 0? Well, if you have a point here, then the argument of this would be 90, and the argument of this would be 90. So it's going to be greater than 0. It comes off the edge of the circle. And then any point in here, the difference is 90. Okay, good.